Welcome to clickmyproject.com.
It is our project title. Our project title name is a future reduction fuzzy clustering algorithm based on future weighted entropy. It is our project abstract. In our project abstract, the fuzzy clustering algorithms is generally treat the data point with future components under the equal importance. However, there are the various data sets with the irrelevant features involved in the clustering process that may cause the bad performance for the fuzzy clustering algorithms. That is, the different future components should taken for the different importance. In our process, we present a novel methodology to improve the fuzzy clustering algorithms that can be automatically compute the individual features weight and simultaneously reduce the irrelevant future components. In the fuzzy clustering, the fuzzy C means FCM algorithm is the best known. We first consider the FCM is the objective the function with this future weighted entropy and construct the learning schema for the parameters and then reduce the irrelevant future components. We call in the future reduction the FCM is FR of CMs during the processing. The new procedure for this eliminating the irrelevant features with the small weight is created for this future reductions. The computational complexity of the FR-FCM is also be analyzed. Some numerical and real data set are used to compare the FR-FCM data various future weighted FCM. Experimentally, the result as the comparison actually is the demonstrate this the good acceptance for this FR-CFCMs with this the effective and usefulness is the practice and analysis the useful tool for this data analysis. It is the method for the finding the groups with the data with the most similarity and the same clustering and the more similarity between the different clusterings. We introduced the new idea for the practical the membership description for the membership the function. It was the successfully applied in the clustering the C star and partition of the fuzzy approaches. The fuzzy clustering has been widely studied and applied for this variety of the substantive areas. In general, FCMs treat all the features component of the data to be the equally the important. However, there is the most case of the data sets there is the existing the irrelevant features and it always affect the clustering result during the FCM processing, and this may be the FCM's procedure and incorrect the cluster result. Traditionally, the decision tree the classifier has been handled with is the had and certain value and the data value is this the raised during the measurement or quantities the errors. Multiple the represent the measurement of this the averaging the method is the used for this classify the uncertain data within the has been the mean the variance of the result is the classification is the non accurate due to the uncertainty in the order of the handle the such uncertain data. The distribution the method based on the handle the uncertain data which is the classify the data based on the probability density functions. The pruning technique is the used to the order of the pruning the nodes of the reduce the height and of the tree and component the cost. It is our project flow diagram. In our project the flow diagram, it is our the user. The user can be load the data set. Yes, the medical relevant information can be loaded for this in this flow diagram. The user can be loaded the data set. The data set can be first it can be verify this structured or non-structured format. If the process is in structured format, it is not problem to load this data. If the unstructured format, the for example CSV and Excel and any other formation, this process can be check this data. The unwanted information and unwanted information can be removed. This so it is in the pre-processing technique. In this data pre-processing, the all of the unrelevant information and null value data and this information can be removing this in this process, and later this data can be goes to this entropy classification. Entropy is one of the technique. It can be classified this technique for based on some of the attribute based clustering classification. It can be in this process can be take this after the classification process can be completed, it is goes to for analysis. The entropy classification is a normal classification technique. It is but it was classified this attribute based classification at a to a of I to a of n. A of j is an some of this attribute based classification number, and it is an a up to a of n means it can be end up to end it can be classified that. So this it is the special for this analyzing classification, so the user can be easily understand this classification technique. So this classification can be completed after it can be goes to this average tree. This clustering process can be completed, can be used for this all of this word and clustering count can be displayed. So this clustering count based average graph can be created in this process. If the graph can be verification, if the graph can be all the cluster count can be verified in this process. If the error of this error some of this graph count can be not verified, so it is the clustering can be another time it can be also goes to this entropy classification. This process can be continue. So if the process can be completed, so it is goes to this pre and post prune. The pre and post prune is a technique. It can be displayed as all of this clustering result from the for each and every result. So this pre-process pruned technique can be completed. It can be goes to this data clustering result. In this process, the data clustering result can be give the all of this cluster result, and it can fuzzy based cluster result. This fuzzy based cluster result graph can be created in this process. This graph can be viewed for this in this user can be view this graph result. It is our project decision tree. So open your project pages, and it is in first page is in start page. So click this start page and right click this run file. If you click this run file, our project can be start to run. It is our project home page. Our project title name is a feature reduction fuzzy clustering algorithm based on future weighted entropy. So click this data mining image. So it is goes to this another frame. In this process, so it is in first process to choose the data set. So click this choose button, so goes to this data set. It is breast cancer.txt. It is our data set. So click this open. So it is view, it is our the details of this our data set data information can be displayed. So it is an id for patient id, and some of this single in it is in data heart cancer, and it is in the breast cancer information can be displayed this field. So it is in all of in attribute of this breast cancer attribute. So it is in classification. So click this classification. So classification can be completed. So it is in a subtable 1 or subtable 2. So your user can choose any of the subtable. It is in subtable means it is taken for this subtable information can be displayed this field. So it is otherwise it can be classified subtable 1, and it is in subtable 2 otherwise classification. So we can be divided into the data from this subtable 1 subtable 2. So I can be taken for the subtable 1. So it is in entropy. So entropy is an entropy classification. It is a clustered calculation. Entropy result can be displayed. So it is in gain a of d. So it is in milestones of the gain, all of gain milestone information can be displayed. It is in probability. It is a probability a of j information can be displayed this field. For each attribute the a of j can be clustered information can be displayed this field. So it is in a of just clustered. So it is in a of j to a of n information can be displayed this field. So it is in probability 5 point. It is in cluster result can be displayed this. It is in floated result can be displayed. So it is in average. So it is in total number of sum means it is sum result can be displayed this field. All of information sum clustered sum result can be displayed. So it is in mean means it is redundancy mean result can be displayed this field. So it is an AVG average tree. So the in this mean result based average tree can be view. So click this tree. So it is in a breast cancer information based. It is an attribute. So it is in mean based attribute clustered information based and mean based tree can be structured. This tree can be displayed. So click this goes to next. So it is in distributed tree. It is in distributed based clustered result based tree can be displayed. So next it is in UDF. It is in UDT and PPA pruning. So it is an pre-pruning result. It is a count, clustered count, overall count, and individual count can be displayed this field. So it is in post pruning. It is in post result, and it is in all of information start to end. It is in classification level. All information of this attribute total count information can be displayed this field. So it is in total pure result can be displayed this field. So it is in next. So it is a distributed tree in the after pruning. So it is a distributed result can be displayed this field. It is a normal. It is an total complete clustered structured format result can be displayed. So this it is a format can be right format, and unwanted information, clustered information can be removed this pre-pruning process. So this graph, so this tree can be displayed for this right structured format graph can be displayed, and it is cluster result can be maybe right. Okay. So click this next. So it is an efficient of pruning. So execution time can be displayed. It is in scheduling and existing time can be displayed. So it is in data resourcing and optimal resource optimal. So it is in pruning effectiveness result can be displayed this field. So this result can be click this update. The result can be updated and updated successfully. So this view after all information and the class I can be classify this class result can be displayed this field. Okay, thank you for watching this video.